Hi, this is the lecture overview 3.1 again, second part of this section, and it's on the operations of functions and the domain of those. Problems are really easy to do. The problem is there's so many parts because on your homework there's going to be these four basic operations: the addition, the subtraction, the multiplication, the division. But then they're also going to ask you to find the domain of every one of those. So there's like 8 things per problem. Now, granted, every one of those 8 things is pretty simple to do, but it will take you a little bit of time just simply because of having to put it all in to the computer or on your paper. But when you add two functions, it's like adding the components, just adding the terms. So f plus g of x is f of x plus g of x. So all you're doing is taking the 2x minus 3 on this particular function, 2x minus 3, add to that the g of x, which is x plus 1. So like I said, just add the components. So 2x plus 1x is 3x, and then minus 3 plus 1 is a minus 2. And the domain of this function, the sum, is all real numbers, because 3x minus 2 will take anything you actually put in there. So the domain is all real numbers. Now the next one is subtracting the components. So you'll get the same idea. It's just going to be 2x minus 3 minus g of x, which is x plus 1. And then you subtract the components. So 2x minus x is x. Negative 3 minus 1 is a minus 4. So it's x minus 4. So adding, subtracting functions or multiplying and dividing is the same thing as you do with numbers. So you do with numbers, you just multiply the components or add the components, whatever you're trying to do with it. The domain of this one, of course, taking number minus 4 will be all real numbers. Now, multiplying two functions, well, it's basically, if you've ever heard of FOIL, that's what you're doing in this particular problem, because it's multiplying 2x minus 3 times x plus 1, because f of x is a binomial and g of x happens to be a binomial in this case as well. So in this particular case, you're going to FOIL. And so it'd be 2x times x is 2x squared, minus 3x plus 2x is a minus 1x, and then minus 3 times 1 is a minus 3. 2x squared minus 1x minus 3, you don't need the 1 if you don't want to put that there. But the domain here is all real numbers because there's no fractions or square roots involved. So it's going to be all real numbers there. Then on the division is dividing the component. Now this was actually easier than most problems, and some people think there's too much going on here. It's too easy, and so they try to do something with it. And the moment you do something with this one is when you make a mistake. So when you divide these two functions, 2x minus 3 on top and x plus 1 on the bottom. Now the reason I say that people do too much stuff to this is because they see this and all they did was they put that in and they try to do something with it. You can't divide these two things other than long division, and we're not going to do that anyway. We're going to leave them in fractions. So that's it. That's all you can really do with that thing. Now, well, this must be something to it. Well, there is, because on division, the domain is not always so simple sometimes. Like that one we talked about in the last one, you cannot divide by 0, and negative 1 would make this denominator 0. So it's all real numbers except negative 1. So some of you guys might be wondering, do I do interval notation or do I do it that way? I will discuss that in class, or I did discuss that in class, but it's all real numbers. It's going to be except for negative 1, and so you could say negative infinity to negative 1, union negative 1 to infinity. Which way do I prefer? I don't really care. I'm not a big stickler on that. You're going to find out that I'm not a very much of a stickler on the format of their answers so much as the content. I'm more interested in, do you know what you're doing and how you get the right answer, as opposed to how do you express the answer, the aesthetics of the problem, in other words. So anyway, so then we get down to this last one, f plus g of 3. Now it's really f of 3 plus g of 3, but since I already know what f plus g of x is by this one right here, I'm going to go get this answer by looking at this problem right here, because f of x plus g of x happens to be 3x minus 2. So all I have to do is plug 3 into that function right there. So if I put a number in, I'm going to get a number out. So it'd be 3 times 3 minus 2. 3 times 3 is 9, minus 2 is 7. So 7 is your output. And something else you're going to hear me say in class when you're doing functions, Don't be surprised when you put a number into a function that you get a number out as, number out as the output. And but when you put a variable in or an expression in, you'll get the same out. So there's no saying whatever you get out of what you put in. So you put in a number, you're going to get out a number. It kind of works that way with functions as well. So, but anyway, that ends this one.